Welcome protein coders, let's build some coding muscles. Today we're going to solve a problem, minimum following path sum 2. Okay, so what problem says is minimum following path sum means that from starting row to ending row we have to find a path with minimum possible sum, and with non-zero shift means I can move to any below cell but not in the same column. Okay, I can't move in the same column. That's the condition for non-zero shifts. Now let's see what will be our thought process. For every cell in the bottom row, we will call a solve function. Okay, what this solve function will do is it will calculate the minimum path sum, okay, from the given cell in the bottom row to the start row. Okay, we will move in the reverse direction. And at the end, what we will do, we will take the minimum of all the minimum path sums which we will get from every element in the last row. Okay, so let's quickly write our solve function. This will take two variables I and j, our row value and row index and column index. Okay, let's initialize a mini variable initially with int max, and let's run a for loop for all the columns in the upcoming previous row. Whenever the column is equals to the j, we will continue, or else we will take the minimum of all the values, okay, in the previous row. And for this we will call the solve function recursively. Okay, at the end we will return the minimum value plus the grid ij. And for the base case, if I becomes 0, we will return simply the value of the grid at that point. Okay, so let's quickly code this up. Let's initialize our answer, and what we will do, we will call the solve function for every element in the last row, and we will take minimum of all of it. Now let's quickly write our solve function. Let's initialize mini, and I am writing new j. Okay, for better understanding, if new j equals to j, we will continue, or else we will get the minimum of all the values in the previous row. Okay, for base case, if I is 0, we will return the value of grid at that point. And yes, congratulations, we got time limit exceeded. That means we need to memoize our solution. Let's see how we're gonna do it. So you see, if you observe, our I value is going from n-1 to 0 and j value is going from n-1 to 0. So we need a 2D vector for storing every ij value. Okay, every recursive call for ij. So let's create our 2D dp vector of size n cross n, and let's pass it everywhere, in our function also, in our recursive call also. And at the end, before returning, we will store dp of ij, right, the value in dp of ij, and also we will insert a check. If dp of ij is not equals to -1, we will return dp ij. Let's quickly submit this, and we have passed all the test cases. Now in Memoization, we have moved from index n-1 n-1 to 0, 0. So in tabulation, we will move from 0, 0 to n-1, n-1. Okay, and from the base case, we know that minimum path sum for the first row will be same as the value in the grid for the first row. Okay, and so we will have two for loops, and I will move from 1 to n-1, and simply I will copy the recursive code, recursive logic, and instead of function call I will write dp. Okay, similar process which we have done in our previous questions also. And at the end, what we will do, we will take minimum of all the values in the bottom row. Okay, now let's quickly implement this into the code. So at the end, instead of solve function, I will write dp n-1j. Okay, now let's fill the first row of the dp vector. Now let's write our for loops. I will be from 1 to n-1. Okay, keep this in mind. Let's take our mini, and let's run our internal for loop for new j. If new j is equals to j, we will continue, or else we will calculate the mini, and dp of ij will be mini. Let's quickly run this, and yes, We have passed all the test cases. Now let's see how we're gonna space optimize our code. So if you observe in our recurrence relation, we are dependent on just the value in our previous row to get the current row value. Okay, so we don't need to maintain the whole DP. We can simply maintain two vectors, one previous and one current. Okay, so let's quickly remove our DP vector and let's create previous and current. And for filling, instead of filling first row, we will fill previous. Okay, and instead of dpi minus 1, I will write previous, and dpi will be replaced with current, and after that previous current will be assigned to previous. That's it. Now let's quickly submit this, and again we have passed all the test cases. Okay, now there is one more thing I want to discuss in this question, but before that let's quickly talk about time complexity. For recursive case, we have n multiplied by, for every cell I am having n minus 1 options, so it will be n minus 1 to the power n, okay, which is exponential. For memoization case, right, I am running 2 for loops for n times, so it will be order of n cube. For tabulation also it will be order of n cube, but for space optimized, the space will reduce to 2 times n. Let's observe how we are filling our DP table. So this is our DP table. Okay, how we are filling this is, let's say I am calculating the value for this element here at index 1 comma 1. Okay, so DP of 1 comma 1 will be first the value at this point in the grid plus minimum of all the elements in the previous row except the same column. Similarly, if I am calculating for DP of 1 comma 3, it will be the value of grid at this index and minimum of all except j equals to 3. So instead of calculating minimum for every ij value, I can simply calculate pre-compute the minimum value. Okay, this will remain same for every element in this row, in the previous row, and if the minimum has the same column as that of element, then I need a second minimum. Okay, because I can't use that minimum. So earlier for every ij we are running a for loop, okay, from 0 to n to get the minimum. Now we can pre-compute the minimum, and also we can pre-compute the second minimum for the cases when columns become the same, okay, as of the element. So let's rewrite our code in our for loop for I, and we will also maintain an index, okay, to get the minimum value index to check for the same column case. So first let's find the minimum and minimum 2. Okay, it's the same function which you have done in your early classes of the array data structure. Okay, same to find the minimum 1 and minimum 2. Okay, and then we will calculate the next row of the DP vector. So current j will be grid ij plus, now here if j is equals to idx, if the column value is equals to the column value of the minimum, then we will add minimum 2, or else we will add minimum. Rest will be the same. Let's quickly submit this, and yes, our answer is accepted. So now our time complexity is, if you see, so earlier it is order of n cube, right? This n is for this inner for loop, and now because we are pre-computing our minimum values, then it will be of order of n square. Okay, so which is much better than our previous approaches. Okay, so that's all from my side, guys. You will find the problem and the solution link into the description box. If you have any queries or suggestions, please mention them into the comment box. I hope this helps. Let's meet in some other video. Till then, keep smiling, keep practicing. Thank you.